look at that. I am crossfading over here. This is me, John Park, and welcome to John Park's Workshop. How y'all doing today? Welcome back. Okay, Matambale over in our Discord chat just called that song Syncopated Mathematicationator. I like that. I can't say it, but I dig it. So that is... that's how we're going to start things. So, hey, Happy New Year. It is 2019. Can you believe it? I can believe it. I saw it happen, and here we are. I'm excited to be back. Had a little break last week, and now we're here to build some stuff together. So how about that, huh? So I hope you had an excellent holidays and New Year's. And I am... Let me just hide some stuff here so I don't get distracted. Hello, Facebook people. Oh, someone's saying hi in there. Hi. I don't usually get over to that chat. There's too many chats. But if you are interested, speaking of chat, in joining the chat, please come on over to Discord. The Adafruit Discord server in the live broadcast channel is where it's happening. And sometimes we get some people over there in the YouTube chat as well, but the main thing is over there in Discord. So, hey, let's start off with a couple of little announcements. First of all, we've got a great jobs board over at jobs.adafruit.com. So if you are in the market for a job or some contract work, or you're looking to hire someone for a job or for some contract work, head on over to jobs.adafruit.com. Now, with no further ado, we've got our discount code, DISCUS, D-I-S-C-U-S. That's going to get you 10% off in the store today, Adafruit store, on all the good stuff that you want, excluding software, gift certificates, and subscriptions. Hi, Andy Calloway, over in the Discord chat. Welcome. Look, it's 2019, and here we are. I'm going to get a sip of water. Pardon me. Watch this. I'm going to fade out as I gulp the water. There you didn't have to hear that gulpy noise. All right, let's bring that level back up. So yes, 10% off in the store today until midnight sometime, maybe East Coast time. You can get 10% off by entering in the coupon code DISCUS. So go do that. And you know what? That leads us right into the product of the week. And I will tell you what the product of the week is this week. It is the Feather M4 Express with the SAMD51 chip on it. I've got one that I'm going to be using in our project today. Is this one here? I think I've got one right here, in fact. Yes. Let's pull one off of this board. There it is. That's that delightful Feather. This is the board you want. It says it right there. Look, if you look at the product page, if you scroll down in this product page, I'm not making this up. It says, it's what you've been waiting for. Because that's what you've been waiting for. We've all been waiting for this. This board has so much horsepower. It is $22.95 in the store. You're going to get 10% off if you use that coupon code. It's in stock, and it's fast. It's beefy. It's got 0.5 megabyte of SPI flash on it. You can program it in CircuitPython. You can program it in Arduino. I'm going to use one in the project today. I love this one. It's got a couple of analog outs, which is nice, real DACs on it, so it's really a big improvement over previous boards which only had the single one, because once you start getting into projects that need a DAC, you kind of want more than one. There's always ways to go beyond that, but it's nice this one has two. What else to say about it? It's a Feather, so it uses all the feathers in the ecosystem. The feather wings can plug into it. We're going to be using it today with the Cricket Feather Wing. It's one of the first real projects I've done with the Cricket Feather Wing, in fact. And what else? It's got LiPo battery recharging on it. You can program it over USB really easily. It's got a little proto area on it. Super great board. I love it, love it, love it. I can't think of a reason to use the M0 anymore when I can use the M4. So go get yourself an M4. They're awesome. Yeah, that's it right there. Look at that beauty. Big fat chip on it too. If you compare that to one of your old M0s, you'll laugh, because the thing is just huge on there. Gigantic chip. All right, that was the new product. Hey, Dave Estells, you made it over to YouTube. Dave Estells gets a very special shout out today because he wrote the code for my project. I had made a stab at it, but it had some complexities to it that I wasn't prepared to handle in time. And this is a project that almost did me in. You ever have one of those projects? This one has had comical amounts of missteps on it. But Dave came in and gave me some advice on how to approach it, and then wrote some code that I think is going to be rolling into a library for debouncing, because we wanted to do some edge detection for our project. And anyway, big thank you to Dave Estells. And go check out some of Dave's guides. They're fantastic over in the Learn system. Okay, well, let's get something set up here. Let's get that there. Let's go to this here. That's right, it's the Make Code Minute. And look, this is Make Code, and I'm right inside the Make Code. So for today's Make Code Minute, what I'd like to do is talk about using an external NeoPixel strip on the Circuit Playground Express in Make Code in order to graph the light level in the room, or as you cover up the light sensor. So here you can see in my Make Code session, what I have is an on-start block where I set a strip to a NeoPixel strip on pin A3 that has 30 pixels. If you're wondering where that is, just click on this category called Light, and then this NeoPixel category shows up. And right there we have set strip to, and it defaults to A1. I'm moving it to A3, just for fun. So I've got that in my start loop, and then in my forever loop what I've got is, again, under Light, NeoPixel, I'm setting a strip graph, and it defaults to, say, 0, and then you can add more things to it. All I'm doing is adding, instead of that 0, I'm graphing in a light level. I got that from input, and if we scroll down in input, you'll see light level. So with that running on the board, check it out. I'm going to take this strip of NeoPixels and wear them like a proud bandolier and try to get out from under the Make Code. And then you can see as I block the light on my Circuit Playground Express, we are graphing that lightness value up and down the strip. So you can make that sound reactive, use a potentiometer. There's lots of ways to do it, but this is a really quick and easy way to do a reactive prop using Circuit Playground Express running Make Code. And that is today's Make Code Minute. Yes, that's it, right? How about that? And I'll point out I've got that really cool Mike Dole designed case on my Circuit Playground Express, which I really dig. And these are these 30 NeoPixel, let me zoom out a little bit for you, strips that have alligator clips, so they're dead easy to just clip onto a Circuit Playground Express and off you go. They work fantastic. They run off of the 3.3 volts on here just fine. So these are perfect for getting stuff set up really quickly. If you're using them in a classroom setting, teaching, it's really nice to have a good solid alligator clip connection that's already built onto here and you don't have to solder anything on. So I really dig those NeoPixel strips that have the alligator clips for use with the Circuit Playground Express. Okay, so let's get that out of the way. And let's see, so last week I built my little keyboard. I have it over there. I actually forgot to test if it's working today, so we'll find out. It should be, why not? And what I'm going to do is head over to the workbench, and we're going to take a look at the project of the day, or project of the week, which is an optical mechanical drum sequencer, or could be any sounds that you want, that looks just like that. Let me put the little corner view up. And I'm going to head right on over there. So you may have or may not have ever seen this type of setup before for a sequencer, but the way this works is that we have different rings of notes that can be activated, in this case, wherever they're black, that's where we're going to play a note. So you can think of it kind of like a piano roll. If you think of a player piano, how the notes are punched out where it's going to play. It's similar to that, or like a music box where you roll a piece of paper through, and wherever there's holes, the little hammers actuate or tines actuate on the drum. So this, instead of using suction and valves in the case of a player piano, or a mechanical finger in the case of a little piano roll or music box, this instead uses reflection sensors, and these are infrared. It's a little package that contains an infrared LED and an infrared receiver. And what they do is the infrared LED is sending out an infrared light source, and that light is bouncing off of a reflective surface like the white paper here, and then is read by the little infrared receiver. When we don't have anything to reflect that light back off of, or it's something dark enough, which isn't perfect in this case, which I'm going to talk about in a moment because this is where I had some problems, it will register that change. So let me go ahead and fire it up, and then we'll talk about how it's made. So it's going to, what we're going to find is I'm going to be doing a whole bunch of fiddling to get the angle just right to get this to play all the notes on here. We'll see if we can get it. And I've got a little speaker built right on here. So I'm going to, it runs through and it checks the notes, and then I'm going to up the speed. Let's see, let's go this way. Okay, it's going to be finicky because we're doing it live, but we can get this. Go a little faster. Now try to get my bass notes in. And one thing I'm going to do is try to block some of the reflections over here. I'm just going to use a piece of felt. So you can hear I'm getting my hi-hat and my clap just fine, but I've got a snare and a bass that I'm not getting to activate. And I'm just going to check the connections on those two. I've got some sort of dead bug wiring going in here, which seemed a good idea at the time, but we'll discuss. This is a lessons learned kind of project. All right, I really want that bass to come in. Come on, bass. It just wants to play that clap. All right, come on. Take this wiring. Oop. So what I'm messing with is the two angles here. Well, you know what? Let me go the other direction. I think I was having better luck in the other direction. Sorry about that. That's a part of the problem. Let's see if we can get the bass. There we go. Yeah, I was reading it in the wrong. That was going backwards. This is forward. Okay, so we got the snare happening now. And I'm going to try to block that again. So I can kind of play it like an instrument, but I'm not getting it to play back exactly what's written here, which is a pain. Closer. There we go. Don't we wish this had happened right off the bat? Yeah. All right, so let's stop there. So what I've got is capacitive touch, which allows me to, I can zoom in here a bit. Capacitive touch on the Cricket feather wing allows me to stop the motor. It's a continuous rotation servo, so I can spin it in one direction. That's the forward direction. Each time I tap it, it increases the speed. It looks like it's at an angle right now where it's really liking the snare and the kick, but not the hi-hat or the clap. We can slow it down, and then we can go backwards, which we saw is actually not so useful. So let me turn that off. Now, let's have a look at the parts and how this is built. So first of all, I've got this array that I built. I think I'm going to try to leave that connected. So I built an array of these little reflection sensors I mentioned before. So this is a package that has that pair. Let's see if you can see those there. There you go. So it has an infrared LED and a receiver there. So there's 4 wires coming out of them. Problem number 1 is when I was first prototyping it, everything was great. And then when I started to solder together my little dead bug circuit, I forgot that the short legs are not ground on both sides. So that had me questioning my sanity for a while until I looked back at the data sheet on it. And so ground is actually 1 long and 1 short on this side, and then the emitter and the collector or the receiver for the signal are on the other side. So what I have is 5 of those, and then each of them are running out to a signal input. There's 5 signal inputs I'm using of the 8 on the Cricket. Zoom in a little closer there even. And so that's where I'm reading whether or not those are being tripped using the Cricket library in CircuitPython. Then I'm also running 3.3 volts up to this top row, and those are going through 220 ohm resistors to each of the infrared emitters, and then also running ground. That's a common ground across everything. So you can see there would be a lot of wires here if I'd run everything discretely, which is why I did some of this dead bug stuff. I do wish I'd used like a little perma-proto board though to make my life easier. So then if we move that out of the way, you can see I ended up using a little wood arm to hold a little camera tripod adapter that actually we sell in the Adafruit store. It turned out initially I had designed this just, with a squared piece, assuming everything was going to work just fine straight up and down. And as I started to realize I needed an angle on there, I added this, which gives me a lot of variability. So then I can lift that out of the way and pop off this disc. Let me zoom out just a little bit. And I'm also going to just pop up my chat over here. Let's see if I can bring up the Discord. Oh, no, my iPad wants to update. No, thank you. Just to make sure you guys aren't screaming at me that you can't see anything, because that's always embarrassing. I do still have my a little alarm that'll go off. Okay, good. No one's freaking out. That's good. So I'm going to pop off this disc, which all this is a piece of acrylic, and I hot glued onto there a typical servo horn. So whenever you buy a servo, you're going to get a collection of different shapes and sizes of horns. So all I did was hot glue that on there so that it can set onto the little splined shaft really nicely. And this is a little hobby continuous rotation servo. I originally was thinking of using a stepper motor because you can control the speed a little better, but that actually requires a lot of calls which would interrupt the reads of the lights. So setting this servo to just go continuously at a speed is much lighter weight on the program. So now let's talk a little bit about the disc itself. So I went through a bunch of iterations of this. I started off with this really naive, ambitious idea of, okay, I'm going to have a ton of steps. So this is like 128 steps possible here. I think I had 64 steps broken out for my different instruments. And you can see they're really tiny. Well, this became difficult to read. At the distances we are with those sensors, they just didn't want to read those very reliably. What this outer track is a timing track. So since we don't have an encoder telling us what kind of speed we're running the motor at, just kind of an approximation, what I decided to do was every time one of these clock marks gets tripped by that outer sensor, it then goes and checks all the other sensors to see if any instrument had played. And this just made some logical sense to me. When I started talking to Dave Estells, he said, yeah, that's great. It kind of keeps the internals synchronized in the rest of the program if we have this to kind of hang our hat on timing-wise. So this is essentially our tempo or click track. So I then, as that was failing, I went to a reduced set of steps, and ultimately you can see I settled on somewhere around, I don't know, 1 a.m. last night. I was like, okay, let's just drop it down to 16 steps. 16 steps is sort of plenty for a typical drum beat. So that's how we arrived at this. I'm sure you could go to higher resolutions if you had a bigger disc, or if you had some different sensors, maybe ones that have a little circuitry on them. Some of them, I think, use a capacitor. But these were so simple that they wanted just a nice big area to trip them. Now, one of the reasons that this, let me try my camera switcher. Let's see what happens. Are you doing anything? Oh, it's doing some stuff. Yeah? Well, hey, that's sort of it. Hi, it's me, trying on my new little camera switcher there that I made, the Andy Clymer keyboard. So one of the early sort of failures I had seemed like a success, which is I hooked up one of these sensors to, I think, just the bare feather, and was playing a wave file and lighting an LED whenever I tripped that LED. But what I was using, I don't know if I still have it here, was a piece of paper that I had cut some, like, every other finger off of so that it would block and unblock. Well, that's ideal, because the reflection on the white versus the lack of reflection on nothing there works great. Then I had switched to one of my early versions of the disc. It was actually this super high-res one, and it seemed to be working. It, in fact, was an error in my code that was causing the wave file to repeat in what seemed like the cadence of that timer thing. So I actually was fooled for a long time in thinking, okay, the basics of it are done. Now I'm going to start modeling this little frame to hold things on. So what I've learned is that the reflectivity of, this is a laser printer, the laser printer ink, direct straight up and down, is too high to register as any different than the white, at least with the type of sensors I'm using. So maybe with an analog sensor you'd be able to sort of hone in on a smaller difference, but I'm not getting it with this. So that's where I started to find angles helped, and you saw me trying to cover it with felt. Dave Estells had an idea, we were chatting about it last night. He said maybe just the ambient light is also introducing an error. So my original frame that holds the little sensors was very skinny, and it basically didn't provide any light blocking. So you can see my later design has just a wider body to it, so that blocks out more light as it goes through. So yeah, fused toner is pretty shiny. You're absolutely right. C. Grover mentions perhaps ink-based marks instead of toner. Yeah, that could be a way to go. I think one of my attempts involved some Sharpie, which didn't seem to change it. I also tried some China marker, because that's kind of waxy and maybe a little rougher. I also had some ideas of using felt. I've got like a nice big piece of black felt here, and I thought cutting that out might be helpful, but I'm so close to this that I'm worried about any surface being raised, or even gaffer tape. I tried using it, but I was bumping into the tape. So, ideally, these would be holes. So if you could use a hole punch, or a laser cutter, or a Cricut, those craft machines or silhouettes that have a little drag knife. Something like that would probably be better. This is, I don't know a lot about how punch cards work, but I'm guessing there's a reason punch cards and little music boxes and player piano rolls all have holes in them and not just marks on them. So lesson learned on there, but what I'm going to do is I'm going to continue to refine this a bit, and I'm still going to put out a guide showing you how to build this, and then I think you can definitely get a success out of it. You saw that as I honed this in and tuned this, it improved. It's possible that by adjusting the brightness of the, adding a stronger resistor to my little IR LEDs so it's a weaker signal of that IR could help. So this could be one where people who want to try it and are interested can contribute to trying to get it to work a little more optimally than it is now. Let's see. Ooh, there's more suggestions. What else? Print onto clear acrylic. Yeah. Light shining through it instead of reflecting it. Are those phototransistors wired? No, these are just digital thresholds, and they're infrared receiver and infrared transmitter. So let's see, what else to talk about? Let's talk about code for a little bit, although largely this is going to be something that Dave Estells can help with as he creates his library. I'm going to open up, let's see, here is my session of Moo that I was using to paste that in there. Let's see, does this look current? Yeah, I think that is, yeah, pretty darned current. Okay, so the way this is working is we are importing some libraries, including a debouncer that Dave wrote as a module, which is going to be a library. So it's a Python file right now sitting in my home directory on my board. Yeah, Mr. Certainly said, very awesome collaboration. Let me tell you, I love nothing more than collaborating with people who have massive Jedi-like skills in areas that I don't. So really fun working with Dave, who's a tremendous programmer, among other things. The voices I'm using are 4 WAV files, and there's no reason you couldn't extend this out. There's 8 sensor reads on just the Cricket, so you could do the click track plus 7 WAV files if you wanted to. Those play at the beginning, so you hear them get cycled through. Also, it checks that they all have the same bit rate and bit depth and sample rate and mono versus stereo. And we set up the audio I/O. The seesaw is instantiated just with the name SS here, you can see. And then we're setting the 5 pins to be that clock read pin and then the 4 voices. So this is working with the CircuitPython mixer function inside of audio I/O. So it allows you to mix multiple sounds at the same time. So in this case, you'll notice in some places I have both the clap and the hat playing, or the hat and the snare playing, and you'll hear them both play at the same time because the mixer is capable of doing that, which is awesome. And this would be, you could do it, certainly it would be cool even to just only play things individually, but it's really nice that you can mix them. And you can also imagine if you chose WAV files that were maybe just standalone notes, so you could play chords. This could be kind of like a chord organ instead of a drum machine. Then let's see. Dave, tell me if there's anything I should point out in here. I have not had a chance to look very closely at how the debouncer is working. So I can't speak to that, but I know that this code is shorter and simpler than what I had in order to be checking for a read on those. So here you can see if voice 1 pin value, so that means that it's gone from 0 to 1, then it plays the voice 0, which happens to be the kick drum, and so on. Dave says, debouncers need to be updated each time through the loop. Okay, so that's down here. I've got my code for adjusting the speed, which was just some simple touch on the capacitive pads. Now, one little trick I used there is that since those 4 capacitive touch pads are pretty close together on the Cricket, I set pin 1 or pad 1 to increase my speed, pin 4 to decrease it, and then I force both pins in the middle to be touched in order to stop it, because it's too easy to sometimes just hit the 2. Well, just hitting the 2 or just hitting the 3 don't do anything, so I'm actually having to mash them both in the middle. Yeah, Dave says then, so it checks, the debouncer checks through every loop to see if the state rose or if it fell based on the previous value and the current value. So that's that edge detection. All right, so let's see. Anything else to say about this? I think I dare to try to put it back together and make it make some little noise, and then we'll wrap up. One other thing I'll point out is that the new speakers that we got in the store, these little 4 ohm 3 watt speakers, actually not so little. These things are beefy. Oh, here's one. These things are great. These put out so much bass for the size of them. I think we originally got these when Noe and Pedro were building a lightsaber with the prop shield, the prop maker shield, and they wanted, or prop maker featherwing, and they wanted a nice speaker inside of their lightsaber that had a fuller sound to it. And these things are great. So let's pop this back on here. I'm going to hold this up so you can see it. And try to get that to be as straight as it can. One thing I also found is that since my distance to the surface is so vital, I was not able to use the cardboard disc that I had originally. It was a little too wobbly. So this cardboard disc, which seems kind of flat, is actually wobbles enough that it was screwing up my reeds. And the speaker is plugged into the speaker output on the Cricut there. And since I promised Dave I would mention this, and I'm going to make a big note about it in my guide, when you first start doing a feather project that involves audio, it is not going to work, and you're going to debug your code for quite a while, and eventually you're going to go back and find a note on our product page and in our Learn Guide that says the audio pin needs to be jumpered. By default, that speaker output is not jumpered, so you have to add I soldered on a couple pins and a little jumper. You could add a switch, you could just put a solder blob across them, but that thing will drive you a little mad when you first try and fail to get any audio out of the thing. All right, so let's tempt fate with another live demo. And turn this on. Get the speed going. Oh, I lost a wire. That's why it's playing that nonstop. There we go. The wire came loose. There we go. I could set finer grained BPM shifts, I think. It's pretty extreme right now. And there we have it. That is your CircuitPython disk sequencer. Thank you so much for coming by the show. I'm going to go hang out in the chat a little bit. Maybe I'll stop this thing playing. I'm just excited it worked as well as it just did there. Finicky project. You just have those projects every once in a while. So that was mine. And I hope you enjoyed the show. And one last time, I'll mention our coupon code. If you want to head over to the store, get yourself a Feather M4, get yourself a Cricket Feather Wing. You can get these. They're in stock. Get a continuous rotation servo, a bunch of reflection sensors. Boom, you've got a drum sequencer with a little work, on top of that. But there's your code, Discus. That's going to get you 10% off in the store. And that is all I got for you today. So thank you again so much, and I will see you next week. Bye-bye.